Hello everyone, in this video I'm going to explain Prim's algorithm with an example. Prim's algorithm is used to find minimum cost spanning tree and it is a minimization problem. A spanning tree says that the number of vertices in a spanning tree should be same as that of the number of vertices in the given graph, and the number of edges should be 1 minus the number of vertices. That is, if I have 7 vertices, the number of edges I should have is 6. The spanning tree should be a connected graph, and since it is a minimization problem, the cost of the spanning tree should be minimum and there should be no cycle in the spanning tree. Now let us see an example. Here is an example given which has 7 vertices and it is a graph with weights assigned to each edge of the graph. Now we need to derive a minimum cost spanning tree, or we need to find a minimum cost spanning tree from the given graph. It is said that a minimum cost spanning tree should have same number of vertices as that of the given graph. So here there are 7 vertices, so hence your spanning tree also will have 7 vertices, but we are going to choose edges in such a way that the cost will be minimum and there will be no cycles in the graph. So you can start with any of the vertex, but in this case let us start with the vertex 1. So from 1 we have 2 edges that is coming out of 1, which is connecting to 2 different vertices, that is 2 and 6 respectively. Let us see the weight of both the edges. The cost of distance from 1 to 6 is 10 and the cost of distance from 1 to 2 is 28. From this we'll choose the edge that has minimum cost. So the minimum cost among 10 and 28 is 10. So we choose 10 and we draw the edge between 1 and 6 with cost 10 in the minimum cost spanning tree. Now moving on, we have started from 1, we reached 6. Now we should see all the edges that is coming out from 6 connected to different vertices. Now when we are choosing all those edges from 6 which are connected to other vertices of this graph, we should keep in mind the previous edge that which we have not chosen, which was from 1 with cost 28. That should be kept in mind. Now from 6 I have only one edge that is connecting with the vertex 5. Now look at the cost of this edge. It is 25. The cost of one more edge which we have not considered in the spanning tree but which is in our mind is 28. Now among 25 and 28, check which is the minimum. The minimum is the edge which is connecting 6 and 5. So I connect this edge between 6 and 5 with cost 25, but make sure that 28 is still in your mind. Now moving on to the next stage, we have to find all those edges from 5. We started with 1, we reached 6, we chose 6, that is the cost 10, and then we chose the edge that is connecting from 6 to 5 with weight 25. Now from 5, check which all are the edges that is going out or connecting other vertices. We have one edge from 5 to 7 with weight 24, and we have another edge from 5 to 4 with weight 22. We have one in our mind, that is 28. Now among these three, 28, 24 and 22, which is the minimum cost? The minimum cost is 22. So we will connect the edge from 5 to 4 with weight 22. Now since we have connected from 5 to 4 with weight 22, the edge which we have not chosen is 24 and 28. So make sure that you have in mind the edge with weight 28 and 24, which I have marked here in red. You need not mark it, this is just for remembering. Alright, now we will move on. We have reached 4. So we have reached the node 4. So let us find all the edges which is coming out from 4 connecting different vertices. So we have an edge 4 to 7 and 4 to 3. So from this 4 to 7 and 4 to 3 and all those edges that are in our mind, that is 28, 24 and 28 and 24, which is the minimum cost. We have an edge 4 to 3, that is 12. We have an edge 4 to 7, that is 18, and we have 24 and 28 in our mind. So which is the minimum cost? The edge that is connecting from 4 to 3 with weight 12. So we will join or will connect 4 and 3 with weight 12. So we have three things in our mind: one edge with 18 weight, another edge with weight 24, another edge with weight 28. Now we have reached 3. So we will find all those edges which is coming out from 3. We have one edge which is going to 2 with weight 16. Compare 16 with all the other edges that is in our mind, that is 18, 24 and 28. The minimum weight is 16. So we will connect 2 and 3. So 2 and 3 is connected. Think, yeah, from the edge from 3 to 2 is connected with weight 16. Now we have reached 2. We have to find all those edges from 2. We have only one, we have one edge from 2 to 7, that is 14. One is already taken, because if we consider 1 2 to 1, one was already considered. If we consider 2 to 1, it will become a cycle, right? We should not have cycle in the spanning tree. So we consider that since there is only one edge which is from 2 to 7 with weight 14, compare this 14 with all the edges in our mind, that is 18, 24 and 28, which is a minimum cost. Minimum cost is 14. So we will connect 2 to 7. So we have connected 2 to 7. Now check whether, each time you should check whether it is forming a cycle. It has not formed a cycle in any of the stages, as well as we have connected all the vertices, right? There is no disconnected graph here. It is all the vertices are connected. And check the number of vertices. 1 2 3 4 5 6 7 vertices we have. Check the number of edges. It should be 1 minus the number of vertices. So I have 1 here, 2 3 4 5 6 edges. So 7 minus 1 is 6. So it satisfies all the condition of a spanning tree, that is number of vertices v is equal to the number of vertices in the given graph. Number of edges is v minus 1, that is number of vertices minus 1, and it is a connected graph. There is no disconnectivity between the element or the vertices of the graph. Also, the cost is minimum. With this you will get the minimum cost, and there is no cycle in the spanning tree. Hence, this is how you construct or you find minimum cost spanning tree using Prim's algorithm. Yeah, that's all for this session. Thank you.